Hello students, this video is to help review for the Unit 7 test. It's the Unit 7 review packet. This is the first part of a 2-video series. I wasn't able to record a video that had all the answers on it because I just can't speak that fast. Anyway, hopefully you tried these questions already. If you haven't already done so, please pause the video, try these questions out, and then see if you got them right. In the first couple of questions, you may notice that I rearranged the questions from year to year. I tend to rearrange the questions a little bit, so if you don't see this as your first question, just sort through until you can find it. I moved all the multiple choice to the front recently. In question number 1, it tells us that altitude CD is drawn to hypotenuse AB of this right triangle. You know that an altitude of a right triangle creates a situation where there are 3 separate right triangles and all of them are similar to each other. So in order to figure out what similarity ratio we're going to use, we simply label all 3 sides of the triangles that we have information for, and then we look for the things they have in common. For example, in this case, I don't have the hypotenuse of this triangle, I don't have the hypotenuse of this triangle, but I do have a long leg for both of these triangles and a short leg for both of these triangles. LL is long leg, SL is short leg, and you'll see I do that throughout the course of the video. I can see that short leg and long leg for each triangle is labeled, so I'm going to set up a proportion being short leg over long leg equals short leg over long leg. Then I substitute the information. For example, the short leg and the long leg of that smaller triangle is 3 and x respectively. That's what it shows here. And then the short leg and long leg of the larger triangle is x and 12 respectively. That's here. I cross multiply. Sometimes we call it crisscross applesauce. If you're cool, you get x squared equals 36, and the square root of both of those gives you the fact that x is equal to 6. For the second question, we're doing the same thing. We're taking the triangles and splitting them up into 2 separate triangles. Now notice that there can be 3 possible triangles, but the trick that I always use is I look for whether I know information about the triangles. If you look at this triangle here, this medium-sized triangle inside this diagram here, I don't know the measurement of CD, I don't know the measurement of CB, and I know only part of the measurement of DB. I know that the whole thing here is 36. I don't know what this part of it is though. Since I don't know anything about that triangle, I'm going to skip it. I'm going to go to the other triangles, and you can see that I know the short leg and the hypotenuse of both of these example triangles. So it's asking for the length of AD. Most of the time I just label that in as x right away, and then I can set up my proportion in the same way. Remember, this one was short leg over long leg. This is short leg over hypotenuse. It doesn't matter which pair of sides that you're going to use as long as you're consistent, as long as these match up with these. If I have short leg and hypotenuse here, I can't use short leg and long leg here. It has to be short leg and hypotenuse. And I'm informed about which ones to choose by looking at the diagrams. I have short leg and I have hypotenuse. That's why I choose these 2. It's as simple as that. We're going to get into the trigonometry unit very soon, and in the trigonometry unit we do the same thing. We look for what we are given, what information we can use, and we apply it. For question number 3, we did a very similar thing. We're doing short leg over long leg equals short leg over long leg. I installed that equal sign there. We're looking for the length of BD. It's always given to us in the triangle or in the problem what we're looking for. So BD is here. I put that X there, and that means it's shared between these 2 smaller triangles in the diagram, which means I pull apart the triangles and I label that as X. It's the long leg for this one and the short leg for this one, so it looks like I have short leg and long leg here. I have a long leg and a short leg here, so I'm able to put it together. I do have the hypotenuse of that larger triangle, but I don't have the hypotenuse here, and I don't have the hypotenuse here. Remember, you're being strategic about what you have. In this case, we had to do a little simplification of radicals. We get x squared is equal to 63, and there's no perfect square. There's no square root of 63 that is an integer value. So what I can do is I can take the square root of 63, which is the square root of 9 times the square root of 7, and I identified 9 as a perfect square, which means I can take the square root of 9, which is 3, and I have to leave that square root of 7 inside the radical. You should know by now how to simplify a radical expression. For question number 4, we're doing short leg and long leg, short leg and long leg. I split up the triangles only using the information that I had. The most difficult part of this one was that it didn't give me what the triangle actually looked like. I had to draw it myself, but the first thing says that PRQ is a right angle. You basically have the whole triangle from there. The first thing I did was I drew PRQ as a right angle, and that basically tells me I'm just going to connect P and Q together. That's my right triangle. Then it says RT is drawn. I'm going to go from R to a point along the hypotenuse, and I'm just going to label that a point T. I must make sure that it's perpendicular to that base because RT is drawn perpendicular to the hypotenuse. In other words, RT is an altitude. I cross multiply from there, and I get 36 is equal to 4x squared. I divide both sides by 4, and square root, I should get my answer. Notice that in all of these cases, I set up the proportion, I cross-multiplied, but before I cross-multiply, I can verify that I set up the proportion correctly, because every single time the proportion should have two of the same elements on a diagonal. I have a 6 and a 6. I have a x and an x. I have a 12 and a 12. I have an x and an x. Every single time it should look like that. All right, moving on to the next page, question number 5, 6, 7, and 8. Pause the video, try these out, and then see if you got them right. All right, for question number 5, it was looking for CB. Notice I had to get a little creative here. I had to show that AB was AD plus DB, which is, in other words, 7. I also know that CB is the thing I'm looking for, so I label that as X. That's going to be the hypotenuse of this smaller triangle and the longer leg of this larger triangle, but we do have long leg for both of these triangles, and we do have hypotenuse for both of these triangles, which means I'm doing long leg over hypotenuse equals long leg over hypotenuse. Some questions that students ask come up in the videos. One of them is, can I do hypotenuse over long leg? Yes, as long as you do hypotenuse over long leg here. I always like to do smaller number over larger number. That keeps me honest. And again, I have the diagonal having that same number here. Cross multiply, and I do have to simplify radical here, but that's not too bad because I know the square root of 28 has the square root of 4 in it, and that becomes just regular old 2. For question 6, it's the same idea. I'm looking for the things that they give us. Well, I have a hypotenuse, I have a short leg, but I don't have a long leg. I have a short leg, I don't have a long leg, and I do have a hypotenuse, so I'm using short leg and hypotenuse. I check my diagonal. I have 2 x's here, so I'm doing something right. And then I cross multiply and simplify. For question number 7, it was a little bit different, but it was in this unit. We talked about dilations. Remember that dilations have the same slope, and they also have a dilated y-intercept. So the first thing I did was I took the equation that they gave us, and I solved it for slope-intercept form. So I identified that the slope was -2, and the y-intercept was 1. Remember, same slope, so I don't have to change that. I don't have to do perpendicular slope, which means negative reciprocal. I just keep it the same slope, so the same slope would be -2. I do have to dilate the y-intercept, which means I'm going to multiply it by 4. That's the scale factor. So my y-intercept is 1. I multiply by 4, and I get 4. So my y equals mx plus b. My linear equation should be y equals -2x plus 4. The -2 comes from the slope. The 4 comes from the dilated y-intercept. Boom. For question number 8, it's a perimeter question. These perimeter questions are based on the idea that we know something about the triangles and we can add together those pieces to get a perimeter. I've outlined the trapezoid that they're asking about, and I've also underlined this pesky word equilateral, which means equal sides. We're going to get to that in a second. I know that EF is a midsegment because it talks about E and F being the midpoints. If you connect 2 midpoints in a triangle, you're making a midsegment. You also know that midsegments are half of their opposite side. So I look at the opposite side, which is 7x minus 2, and I compare that to 2x plus 8. I know that 2x plus 8 times 2 is going to be equal to that longer side because this piece is half of this. So if I have to multiply this by 2, I get it to be equal to that. I do the distribution, I simplify, and I solve. X is equal to 6. And then I'm going to substitute in 6 for all of the measurements that I have. The midsegment is going to be 20. And this side is going to be 40. But remember, it's an equilateral triangle, which means AC is also equal to 40 now, and CB is also equal to 40, because this side is 40 and it's equilateral. That means that FB and EA are going to be 20 each, because it's an equilateral triangle, which means this side is 40, but it's a midpoint. F is a midpoint, as it says over here. F is the midpoint. So that means this side is going to be 20, this side is going to be 20. I'm looking for the perimeter, which means 20 plus 20 plus 20 plus 40. That's going to give me 100 in total. Moving on to questions 9, 10, and 11. Pause the video, try these out, and then come back to see if you got them right. All right, we're looking at right triangle ABC shown below. It's a very similar question to the other questions that we've done before. We have an altitude drawn to a right triangle, which means I can create 2 similar triangles from it. I can actually create 3, but I'm only going to look at 2. In this case, I need this triangle, which is the whole entire triangle, and I also need the left-hand triangle. I label these sides as hypotenuse, long leg, and short leg, and I look for the commonalities. I have a short leg for both of them, and I have a hypotenuse for both of them, so all I'm going to do is set up that proportion, and I get AB is equal to 12. In these cases, since they're short answer questions, you must make sure that you show all your work, and you give an answer that's labeled. Make sure you do that because otherwise, you're not going to get full credit. Moving on to question 10, it gives us some information and it asks us to find the length of segment BC. Well, one thing that you should have noticed is that you are given 2 of the measurements of this right triangle and you're asked for a third. I'm not going to set up a ratio for this because I would need a couple of ratios. Instead of doing that, we're going to use Pythagorean Theorem. A squared plus b squared is equal to c squared. I made the hint in class. It's as easy as ABC, which is very funny. It's a funny joke. Anyway, BC is going to be 5. For question 11, we're told that we have a right triangle. We have its altitude labeled here as x, and we're given 3 and 4. So we split it up into 2 similar triangles. We found short leg and long leg, short leg and long leg. We didn't touch the hypotenuses because they weren't given to us. And then we're asked to find the length of CD in simplest radical form. We cross multiply. We get x squared is equal to 12, which means the x is equal to the square root of 12. I split it up into square root of 4 and square root of 3 because 4 is a perfect square, and then the square root of 4 becomes 2. The square root of 3, I can't do it, so I leave it as square root of 3. So again, I'm labeling this as CD equals 2 radical 3. If you leave it as x equals 2 radical 3, depending on the grader, they might be a jerk and they might not give you full credit. Moving on to questions 12, 13, and 14. These are going to be the last ones of this video. Pause the video, try it out, and then see if you get them right. For question 12, we're looking for the altitude, which is h, and we're actually given quite a lot of information about these triangles. We're given 3, 4, and 5. So we have a little bit of an opportunity to sort of pick and choose our ratio. The easiest way that I could figure out to do this is to look at the largest triangle because I have all the information in that largest triangle. Here's a hint. If you have one of the triangles that you have all 3 sides, you should use it for your ratio because it's going to be easier to pick which one you're given because you're given literally everything. Then I know that I need a triangle that has h in it, so I selected this smaller triangle. I could have selected the other one as well. I would have gotten the same answer. I know that the hypotenuse of this smaller triangle is 3. The long leg of that the longer leg of the triangle, I should say, is h, and I know that the hypotenuse and the longer leg are 5 and 4 respectively of the larger triangle. So I set up the ratio: long leg over hypotenuse equals long leg over hypotenuse, making sure to keep the shorter one on the top and the longer one on the bottom. As I said, that is my preference, and I get a cross multiplication problem. 5h is equal to 12, and then I divide both sides by 5. I get 2.4. No units here, so I'm okay to move on. In this one, though, they do give us units. This should be familiar to you. This was one of the exit slips in the unit. It tells us that from F to P is 12 miles. That's labeled here. From E to M is 10 miles. That's labeled here. And then we're asked the distance on Maple Street from M to P, which is here. Now, in order to do this problem effectively, I needed this hypotenuse. So I showed that calculation. That's just 10 plus x. That's labeled here. So now I have this triangle brought down here, and I know the hypotenuse is 10 plus x, and I know the short leg is 12. Similarly, I know that in this triangle here, the triangle with the x in it, the x is going to be the short leg, and the hypotenuse is going to be 12. My proportion looks a little bit more complicated than in the previous ones, but that's only because the hypotenuse of this larger triangle happens to be 10 plus x. But that's not a big deal, because I can still multiply by that binomial. So I did x times 10 plus x. That turns out to be a distribution problem, so I get x squared plus 10x is equal to 144. I need to solve this like a quadratic equation, and you should know how to solve quadratic equations because this is algebra. You took algebra already. Anyway, you should get x equals negative 18, which you reject, and x equals 8, which you accept, 8 miles on Maple Street. Last but not least for this video, I split up the 2 triangles in this way. I'm given 4 as the altitude, so I just label the sides that I'm given, and I try to do that cross multiplication, which is going to be shown here. All right, here you can see I set up the proportion. I cross multiplied. Here is another example of a quadratic. You must be prepared to solve a quadratic because it is possible that you will be asked this question on the Regents. Anyway, we find our result, which is x is equal to 2. Then we substitute that x is equal to 2 into both of these measurements because we're looking for the length of base AC. So 2 goes here. 2 plus 6 is 8. That goes here. So 2 and 8 give you 10. I could also show that algebraically by first finding the measure of AC in terms of x, and then substituting that value of x in here one time to find AC is equal to 10. All right, this was the video on the Unit 7 review packet. Hopefully this was helpful to you. Good luck studying.